That lack of attention isn't because Ceres is uninteresting. Quite the opposite. The more scientists study it, the more intriguing it becomes. For decades, Ceres appeared to be little more than a large rocky body orbiting quietly in the asteroid belt. Telescopes revealed only a blurry sphere with few obvious details. But everything changed when NASA's Dawn spacecraft arrived in 2015. Dawn had already made history by visiting Vesta, another major asteroid, before continuing onward to Ceres. When it entered orbit around the dwarf planet, it became the first spacecraft ever to orbit two different extraterrestrial worlds during a single mission. What it discovered surprised scientists around the world. As Dawn approached Ceres, one particular feature captured global attention. Bright white spots appeared on the surface, shining so intensely that they stood out even from millions of kilometers away. Speculation exploded. Some people joked about alien cities. Others proposed exotic geological processes. The reality turned out to be less sensational but far more important. The bright areas were deposits of salts left behind by briny water that had reached the surface and evaporated. In other words, Ceres wasn't a completely dead world. It showed signs that liquid water had once moved beneath its surface, and perhaps, under certain conditions, still could. That discovery transformed the scientific view of Ceres. Suddenly, this neglected dwarf planet looked far more dynamic than anyone had imagined. Researchers found evidence suggesting that salty liquid reservoirs may exist beneath portions of the surface. They identified signs of cryovolcanism, a type of volcanic activity where water, ammonia, and other volatile substances erupt instead of molten rock. On Earth, volcanoes produce rivers of lava. On Ceres, similar processes may have produced eruptions of icy slush and brines. It was an entirely different kind of geology, operating in a completely different environment. But the most important discovery wasn't the bright spots. It was what those features revealed about the composition of the dwarf planet itself. Scientists had suspected for years that Ceres contained significant amounts of water. Dawn confirmed that suspicion and then some. Estimates suggest that approximately 25% of Ceres by mass is water ice. Think about what that means. A quarter of an entire world is made of water. In the harsh economics of space exploration, that fact alone is extraordinary. To understand why, imagine arriving in an unfamiliar desert on Earth. You have food, equipment, and shelter, but no access to water. Your survival immediately becomes a race against time. Water determines everything. The same principle applies in space, except on an even larger scale. Water is not merely something astronauts drink. It is one of the most versatile resources in the entire solar system. Water can sustain human life. Water can support agriculture. Water can be purified and recycled. Water can be split into hydrogen and oxygen through electrolysis, creating rocket fuel. Water can shield astronauts from radiation. Water can serve industrial purposes in manufacturing processes. In many ways, water is the foundation upon which a space-based civilization would be built. This is where Ceres begins to separate itself from Mars. Mars certainly possesses water, but much of it is locked in polar ice caps or buried beneath layers of frozen soil. Extracting and processing it requires significant infrastructure and energy. On Ceres, water isn't a secondary resource. It's one of the world's defining characteristics. If future settlers needed vast quantities of water for life support, fuel production, industrial processes, and radiation shielding, Ceres could potentially provide it on an enormous scale. The importance of water becomes even clearer when you consider transportation. One of the greatest challenges in space travel is carrying fuel. Every kilogram launched from Earth requires additional fuel to lift it. That additional fuel requires even more fuel. The problem compounds rapidly, making launches expensive and inefficient. This is why many space engineers believe future civilizations will eventually rely on in-space resource extraction rather than constant resupply from Earth. A settlement that can produce its own fuel gains a tremendous advantage. Ceres may be uniquely positioned to become one of the solar system's most important refueling stations. Imagine a spacecraft departing Earth and heading toward the outer solar system. Instead of carrying every drop of fuel for the entire journey, it could stop at Ceres, replenish its supplies using locally produced hydrogen and oxygen, and continue onward. Such a system would dramatically expand humanity's reach. Suddenly, missions to Jupiter, Saturn, and beyond become more practical. Ceres would not simply be a destination. It would become a logistical hub connecting different regions of the solar system. Yet water is only part of the story. Dawn also discovered organic molecules on the surface near Ernetet crater. These molecules are not evidence of life, and scientists are careful to emphasize that point. However, they are significant because organic compounds are among the building blocks associated with biological chemistry. Their presence suggests that Ceres possesses ingredients relevant to prebiotic processes. In simple terms, the chemistry of Ceres is more interesting than a lifeless rock should be. It contains materials that scientists believe played important roles in the emergence of life on Earth.